Let us study how did Kepler's law help Newton to arrive at inverse square law of gravity. So here, for solving this, that means for finding the expression for inverse square law of gravity, we will go to the previous topic. With the help of a diagram we will study. Here now, two objects of having mass m1 and m2. These are the centers of these two bodies. They exert force on each other from their center. That force is equal to F. Now they are kept at a distance of D. Now in this inverse square law of gravity, what we are going to derive, that only I am asking you here, or that only I am writing here. Now for finding the force, we had studied one equation, that is force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Inverse square law, here you see inverse square law mentioned, that is the force is inversely proportional to the square of the distance between them. But here you see the distance between two bodies mentioned here, D. The question is, why did Newton put D square instead of D? That he is proving with the help of this derivation. For doing that, first we will go again to the Kepler's law. Kepler's which law? Kepler's third law. Here we are going to study now Kepler's third law helped. Understand? Kepler made three laws. Out of them, Kepler's third law helped for deriving this law. Which law? Inverse square law. Here you see now, T square is directly proportional to R cube. Now you see, then T square is equal to this directly proportionality, or the proportionality sign I removed. There I put one equal to sign. Then I am putting here K, then R cube. Now listen children, here T square, then this R cube I brought here, then it will be R cube, that is equal to K. So we can say that this is Kepler's third law. Now one more thing, when we were studying about Kepler's third law, we studied that the orbit of a planet is an ellipse. So we see orbit of the planet, you all know it is not the circle, it is having elliptical shape. Now if we draw a straight line through the center of this orbit, we will get two foci. At one of the foci, their sun remains. Through the orbit, the planet revolves around the sun. When the orbit reaches near the sun, its speed increases. With high speed it moves. Later its speed reduces, then very low speed will become. Again its speed increasing. Finally, once it reaches here, speed increases. This is the movement of orbit really which is happening in the solar system. But for solving this inverse square law, we are considering the shape of the orbit a circle. Now I am taking orbit of a, or considering the orbit of a circle, orbit of a planet a circle. Now you see children, here at the center of this orbit, this is what? This is the orbit of a planet. At its center, X is or remains sun. Now here anywhere we can make the planet, any planet, either Earth or any other planets. Now this planet, its mass I am mentioning as small m. Now we can say that here around the sun through a specific orbit the planet moves. We have to just imagine the planet moves with a uniform velocity. So the movement here, why? Because now we considered the shape of the orbit a circle. Because of that, the movement of the planet through this circular orbit will be uniform. So we can say that the velocity of the planet while it is moving around the sun will be uniform. So we can say that for finding velocity, speed means that we are considering as velocity of the planet. So I am writing here now V is equal to, that means velocity of the planet while it is moving around the sun through a circular orbit. For finding that, we are having one formula with us, that is circumference of the circle, circumference of the circle upon period of revolution. Period means time taking for revolving around the sun. So once again, V is equal to circumference of the circle upon period of revolution. Now circumference of the circle I am writing as 2 pi r upon period of revolution I am writing as t. Now you have to keep in your mind one more important thing, that means when the planet revolves around the sun, the centripetal force on the planet towards the sun we need to find out. That is already an equation we are having. So we can say that what will be the equation for finding the centripetal force exerted on the planet towards the sun. For finding that, we are having one equation with us, that is centripetal force F is equal to mv square upon r. So here now we can say that r is the, here you see m is the mass of the planet, r is the distance of the planet towards the sun or from the sun towards the planet. This distance we can write as small r. V is the velocity of the planet while it is moving around the sun. Now V here, see V is equal to, now you see here velocity we had studied 2 pi r upon t. Now F we have got mv square upon r. Now here this V is there, that place V means what? 2 pi r upon t. So we have to substitute the value of V here now. So we will substitute the value of V in place of V square. See now again F is equal to m into V square means what? 2 pi r upon t, that is V. Now V square means its square will be there. So just to see m into, now V square means 2 pi r upon t. Now V square is there. So we are writing like this. Now its square. Now upon r means just I am writing r here. Then how we can write now? M into 2 square. 2 into 2, that is 4 into pi square into r square, then upon t square. Upon, now again upon is there. There I am writing r. Now you see children here, m into 4 I am writing as, that means this force is common. Now everywhere I am not writing F. Now you see m into 4, that is 4m into pi square r square, now upon t square, again upon r. So now what I am doing, you see, 4m into pi square r square upon t square divided by, this thing I am writing in the division form, I am bringing to this side. So you will get divided by r. R means r upon 1. Same thing we can write as 4m into pi square r square upon t square into 1 upon r. Now we will calculate it. Then how will be the answer? Therefore, F is equal to 4m pi square r square upon t square into r. Now what we are going to do? See here, 4m pi square r square upon t square into r. Now we are multiplying both the side up and down with the r. So now we have to multiply both the side with the r. Then what will be our answer? So here I am writing multiplying with the r. Why? Because we have to bring to Kepler's law. For that only we are multiplying with the r at both the sides. Now what will be our answer? F is equal to 4m pi square r square. Now into r is there, so I am writing here r cube. R square into r cube upon now t square, then into r square. Now what I am doing, this r cube I am bringing to down. So you see here now 4m pi square, then r cube I am bringing down to t square upon t square upon r cube, then into r square. Now listen children, t square upon r cube, same as Kepler's law we have got. So we can say that t square upon r cube, that is a constant. So we can write here t square upon r cube is equal to k. Now we are making the equation once again. Here f is equal to 4m pi square upon, now t square upon r cube I am writing here k, then into here, here r square is there, here also I am writing r square. So here now r square. Now 4m pi square upon k is a constant. Again I am writing here 4m pi square upon k is a constant. So we can write here now, is a I am not writing, that I am rubbing. Instead of that we can write equal to. Is a no problem, otherwise we can write equal to constant. So now here this part already gone. Now what is left out? F is there. Now we can say that F is inversely proportional. Here now this value is moving, then at this place there will be 1. So we can write it, F is inversely proportional to r square. See now, F is equal to 4m pi square upon k, that is a constant. After leaving them, here what value will be there? Upside one value is there, downside only r square is there. Now how we can be able to read this? F is inversely proportional to the square of the distance between them. Now you see, you can find now this equation and this equation. Both the place, D is the distance between these two bodies. At the same time, R is the distance between two bodies, that is Sun as well as planet. But here we are written the symbol R, but here we written the symbol D. But value is coming same. This is also distance, this is also distance. Seeing this, he written here the inverse law, or he arrived at the inverse square law of gravity. See here F is inversely proportional to the square of the distance between two bodies. Here again we can say that F is inversely proportional to the square of the distance between two bodies. But two bodies here, these two bodies, so their distance D, but here it is in the circular orbit. So because of that, distance taken as its radius. Distance between two bodies taken as its radius. So here put R. But both of them are distances. So thus Newton arrived at the inverse square law of gravity. Gravity means gravitational force. So this F is the gravitational force between two bodies. Now you see here inverse square law came. That means force is inversely proportional to the square of the distance between two bodies. Thank you.